Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Eva Higginbotham, and this week I've been looking into this question from Matty.
If humans have too many or too few chromosomes, it can cause them to be infertile. So how did different creatures get different numbers of them? For example, humans have 46 chromosomes, but mice have 40.
It's an interesting question. How did changes in chromosome number ever occur if they can cause the individual to not be able to breed to pass on those changes to the next generation? I put the question to Hugues Rost-Crolius. He's an expert in genome evolution at an institute in Paris.
It is true that in humans the total number of chromosomes is 46, and any change can lead to adverse effects, such as in the case of Down syndrome, caused by an extra chromosome 21. However, during evolution, chromosomes slowly evolve and exchange pieces, and they can also fuse or break.
These changes can happen due to mistakes during meiosis, the genetic process by which we divide up our DNA to make eggs and sperm. Importantly, not all mutations in chromosome number result in infertility, as long as the chromosomes haven't changed so much that you can't make any viable eggs and sperm anymore. In fact, it's these changes that can trigger the formation of a new species.
Starting from a common ancestor, after millions of years of this process, two species can end up having very different numbers of chromosomes. For example, the ancestor of placental mammals lived about 100 million years ago, and we think that it had 46 chromosomes. Today, one of its descendants, the Indian muntjac, a species of deer, has only 6 chromosomes, while dogs, another descendant, have 78.
In fact, scientists think it was a fusion of ancestral chromosomes that created the human chromosome 2, and that this could have been an important part of separating us as a species from our close relatives, the chimps, apes and orangutans, who all have 24 pairs of chromosomes to our 23.
The chromosome number can therefore vary quite widely, showing that it is not so important. What is important is the total number of genes that they carry. All mammals, humans, mice, dogs and Indian muntjacs included, have about 20,000 genes on their chromosomes. The many small dog chromosomes carry few genes each, while the few large Indian muntjac chromosomes carry lots of genes, meaning that they both have about 20,000 genes in total. This number of genes is important to carry out all the functions required for the typical mammalian organism.
Given this, it's easier to understand why an extra chromosome 21 causes Down syndrome. It's not so much the extra chromosome by itself, it's all the extra genes that it carries that causes the disease. And importantly, about 30 to 50% of women with Down syndrome are fertile, and some men with Down syndrome have fathered children too. Thanks, Hugues. Next week, we'll be looking into this question from Nancy.
Why does chili stay on your fingers for so long after cooking with them? Even after you wash your hands multiple times, it can still hurt if you touch your eyes.
So, what do you think? You can email chris@thenakedscientist.com, find us on Facebook, tweet @nakedscientists, or join in the debate on the forum. That's at thenakedscientist.com/forum.